Alright, the second lesson in this unit is called multiplying and dividing rational expressions. Now, to do this multiplying and dividing of rational expressions, we're going to do a little review of how to do that with fractions, because really when we're saying multiplying and dividing, we're actually simplifying. And whenever we see multiplying and dividing, what you should be thinking in your head is, how am I simplifying these expressions? So let's take a look at a couple of these fractions here and try to remember how to do this. Now, when you multiply fractions, you multiply across the top, the numerators, and you multiply across the bottom, the denominators. So you could just go 60 over 40. This would be fine. Except that's not simplified. And if you would simplify this, you'd say, okay, I can divide by 10, so that's 6 over 4, and then you'd say, okay, I can divide both by 2, so it's 3 over 2. This is a simplified answer for the multiplying of those two fractions. But I want to see if you remember doing this as well. When you multiply fractions, it's often easier to simplify before you multiply. Alright? So when I see these two fractions, I'm thinking, okay, I'm going to multiply across the top, going to multiply across the bottom. And so I see 12 times 5 on the top, 10 times 4 on the bottom. And I recognize that there is a common factor in 10 and 5. I can divide both of those by 5. This becomes 1, this becomes 2. And then I can see 12 and 4, and I can say, well, I could simplify that too. I can divide both of those by 4. I can divide this one by 4, I get 3. Divide 4 by 4, I get 1. And so now when I multiply, 3 times 1 is 3, 2 times 1 is 2. This is a simpler way to multiply, and we're actually going to use this method with rational expressions. Okay, the idea of simplifying first. So let's try that method with this question. So if you remember, when you're dividing fractions, the equivalent is to multiply the reciprocal. So I take the second fraction, take the reciprocal, and now I'm going to multiply. But before I do that, I recognize a 3 and a 3 here. I can change that to 1 and 1. And I recognize 5 and 20 can both be divided by 5. This is a 1. This is a 5. Sorry, not 5. It's 4. If I divide 20 by 5, I get 4. Okay? And now when I multiply across, 1 times 4 is 4, actually negative 4. And 1 times 1 is 1. But I could just write that as negative 4. Okay, so you guys try this one. Give yourself a little break, pause the tape for a second, and see if you can do this operation. Okay, so you get negative 1 over 6 times 24 over negative 8. Alright, and I'm looking at that and saying, is there anything that I can simplify? Well, I can simplify the two negatives. And then I see that both of these numbers can be divided by 6. This is a 1. This is a 6. And so now when I multiply across the top, I get 6 over 8, which can actually be simplified further. Okay, so there is some operations, multiplying and dividing of fractions. What we're going to do now is take those into rational expressions. So you can see here, one rational expression, here's another one, and we're going to multiply the two of them. Okay? Before I multiply, what I'm going to do is remember that we need to state what the non-permissible values are. And I want to remind you that you should always look for the non-permissible value before you simplify. Because in case we cancel something out, we don't want to forget that there is a non-permissible value. Okay, and in this case, a can't be 0. Alright, going back to the question. Can I simplify anything here before I multiply? I can. I can cross off an a there, and if I cross off an a here, I'm left with a. And then I also see that I could cancel out something with 3 and 9. Both of those are divisible by 3, so I end up with a 1 here and a 3 there. I'm now going to multiply, and I get 2 times 1 times b squared. This is 2b squared. and on the bottom I end up with 3a. Alright, so that's a simplified rational expression. Okay, next one. Again, what do we do first? NPVs. What is the non-permissible value here? Well, x cannot be 0, right? Because if we put a 0 here, this would all equal 0. So it can't have 0. Also can't have a negative 2. Because if I put a negative 2 in here, you're going to end up with 0. So there's my non-permissible values. Alright, now before I simplify, I'm going to see if there's anything that I can cross off here. In other words, cancel out. So x plus 2 and x plus 2 cancel. And just to be clear, what do I mean by cancel? What is x plus 2 divided by x plus 2? It equals 1. So now in place of x plus 2, I have a 1 there. I don't have a 0, I have a 1. Okay? Anything else that I can simplify? Well, I see there is an x squared here, and I see there is an x squared there, right? Those two things together make up x squared. Alright, and so that now I'm going to multiply across. Alright, 2 times 5, this is 10, times x minus 4, and what's left on the bottom, 3 times 8, is 24. And some of you are saying, wait a second, you could have divided out a 2 out of 2 and 8. You're right. We should have done that because now we have to do it here. So if I divide both by 2, I end up with 5 times x minus 4 over 12. And that is simplified. Although you could multiply here, you could go 5x minus 20. You don't need to. I never expect you to do that. This is correct like this. Okay, so that's simplified rational expression. Okay, pause the tape for a little bit, and I want you to try this one, and then we'll do it together. Alright, first of all, NPVs. Now this is going to be a trick. I'm going to put a star here because you're going to make sure you revisit this before your test. There is a problem here. What is the NPV? Well, when you look over there right now, you're going, no problem here, there's no variable. No problem here, no variable. But you also need to consider this. Why? Why do I need to consider that? Well, the reason I need to consider that is because you're dividing. And in other words, none of this can turn out to be 0. Okay? So let's go and figure this out. I'm going to write 7n cubed over 4 times negative 12 over 49n squared. Okay, notice I wrote 49 because 7 is squared and n is squared. So now I want to do my NPVs, and you should recognize here that n cannot be 0. Alright, so there's my NPV. Okay, now let's simplify. Can I cancel anything out here? Yes, I see 2 n's, and if I cancel out 2 n's there, there's 1 n left. Anything else? Yes, I can cancel out a 7 here. If I divide this by 7, I'm left with 7. And one more. I can divide this both by 4. This is 1. This is negative 3. Alright, now if I multiply across the top, what's left? Negative 3n. On the bottom, what's left? 7. That's simplified. Okay. Again, a little trick with the NPVs. What can x not be? X cannot be 0. That's from right here and right here. Okay. X cannot be negative 5. That's from right here. X cannot be 3. Put a little star by that one. That might have tricked you. Why can X not be 3? Well, if you put a 3 there, let me quickly show you what would happen if we put a 3 there. You would have 10 over 3 minus 3, and then you would have 3 times 3, 3 plus 5. You would end up with 10 times 0, which is 0, over 72, which is 0. And since you're dividing by 0, you would have a problem. Okay, so if you need to put a little star by that 3, we'll keep that in mind. Okay, so let's simplify now. I'm not going to multiply because I need it in factored form. And so this becomes the reciprocal is 3x over x plus 5. And now let's see if there's anything that can be cancelled. I see an x minus 3. Cancel it. I see an x. Cancel it. I see 5 and 10 have a common factor of 5. And so now when I multiply, what's left on top in the numerator? Just 3x plus 5. And what's left in the denominator? Just 4. And that's simplified. Okay, so that's pretty much it. That's what we need to be able to do for multiplying and dividing rational expressions. But every time I say that, you know that there's always going to be something that's a little bit harder. And here's the example of what's harder. Why is this one more difficult? Well, the reason is it's not factored yet. You need to factor first. Again, you need to be able to factor. There's just no way around that. Okay? And a little tip here. Generally speaking, there should be something that cancels out. It wouldn't make much sense for me to say to simplify this expression if there are no factors that cancel. Something should cancel. So there should be factors that are in common. That's kind of something you can keep in mind as you're factoring. You should be able to see that there are repeat factors. Okay, so if I factor this one, x plus 5, x plus 4. If I factor the bottom, well, before I factor it, I'm going to take out a 2. Okay, so that's going to make it a little bit easier to factor. And right away you should say, hey, look at that. There's an x plus 4, just like there is in the numerator. Okay, and let's factor this, x plus 1, x minus 1, and here we have 3, x plus 5. Okay, so now I factored it. Before I go any further, let's do the NPVs. It's much easier to do it once it's factor. X cannot be, well, we're looking here, here, and here. This time I don't care about the numerator because we're multiplying. So what are they? Negative 4, 1, negative 5. Okay, anything cancel here? Yes, there's an x plus 4. There's an x plus 5. There's an x minus 1. What's left? X plus 1 over 6. Alright. I think this is the last one. Yeah, it is. I'll give you a couple of seconds to try that. Okay, let's get back at it here. So x minus 2 over 3 times x minus 7. And I'm going to do this in one step here. I'm actually going to do two things at once. I'm going to flip it, and I'm going to do the common factor. Okay, so if I take the numerator and move it to the bottom, I'm going to take out a 3, which leaves me with x squared minus 4. And if I take the denominator, again, I'm going to factor out a 3. I'm left with x squared minus 4x minus 21. Okay, so I flipped it and I factor out a common factor. It's not completely factored yet. You need to do more. Okay, so now I'm going to factor the numerator. I get x minus 7. Hey, did you notice that? There's two x minus 7s. That's kind of something you should be looking for. Factors will have to repeat, otherwise there's nothing to simplify. Okay. NPV, x can't be. Alright, where do we look? We're going to look right here. And then since none of this can be 0, none of the factors can be 0, I have to look here, 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 here. Okay, so x can't be 7, can't be negative 3, can't be plus or minus 2. Alright, let's simplify. There's an x minus 7, there's an x minus 2, and there's a 3. So that leaves me with x plus 3 over 3 x plus 2. Okay. Some homework. Okay, you have page 537, numbers 3 to 8, 11, 12, just do 12A and B, and then 13. All right. Good luck with that.